What's up, folks? This is going to be a fast review video of week 11, day 2. This will not include the instructional video. That is a separate YouTube video. That YouTube video you can find on the actual final assessment on the other slideshow. So, for this do now, why does number 1 work and why does number 2 bad? Number 1 works because when I say 2 out in front, that's saying 2 of everything that it's next to. So a CH4 means that there's like a little 1 here, but we don't use it because it's like we don't say C1. That's too much to write down. Why would we write C1? We know that there's one C right here. I see one C. We don't write out 4 H's. We instead write 4 because it's faster to do it that way. So each of these should have a C and 4 H's, which these do, a C and 4 H's. Not 2 C's and 4 H's. The 2 doesn't apply to the C. The 2 applies to the whole thing. So we got 2 different molecules here. They're not bonded together. They're not bonded together. They'd be touching if they were bonded together. Look, there's space in between them right here. Last class, what we learned is that all 3 of these were the same thing. There's a different way to translate from a chemical equation up top to a model, and the second thing to a sentence down in the bottom. This class, we're going to do some review, some practice, and then the final assessment. A reminder that lab corrections for the Penny Lab are due Friday at midnight. You can only make corrections to questions number 4, 6, and 7. That'll be for Learning Goal 2.3. Learning Goal 2.4, if you want to reassess it, there will be an optional homework this week. Exit ticket review. This is giving you some time to review your exit ticket. Here's some error analysis. One of the errors that I saw was a translation that was this. To make 1 methane over here, 1 carbon is combined with 2 hydrogen gases. What works about this translation is that the student said 1 carbon and 2 hydrogen gases, but what does not work is that they're saying to make methane. It's not to make methane. It's that methane is making carbon and hydrogen, carbon and 2 hydrogen gases. So the make is in the wrong place in this sentence. So we start with CH4, we start with methane, we end with a carbon and 2 hydrogen gases. The left side of the arrow represents what comes before the reaction, and the right side is what comes after the reaction. Another way of saying that is that the left side is the reactants and the right side is the products. The left side is the reactants, the right side is the products. Reactants react to make the products. So if you're on the left of the arrow, you're a reactant. If you're on the right of the arrow, you're a product. And if you're ever wondering, it's always the sentence. Reactants react to make the products. The reactants are what a reaction starts with. We start with methane. The products are what we end with. We end with carbon and 2 hydrogen gas molecules. This is imagining you're baking a cake. We're thinking about reactants you start with and products you end with. The reactants you start with are the ingredients to make the cake. You might think of egg, you might think of flour, you might think of baking soda, and you mix those all together and you put it in the oven. And while it's in the oven, the chemical reaction is happening to make your product, which is the cake. Here's an option, draw your cake. So true or false, the reactants can be same as the product. That is false. The reactants cannot be the same as the product because this wouldn't be a chemical reaction. None of the bonds are changing. It's a carbon bonded to 4 hydrogens, and it's a carbon bonded to 4 hydrogens. This follows the law of conservation of mass, same number of carbons and hydrogens on each side of the arrow, but none of the bonds changed. None of the bonds changed. So no bonds are broken or formed. This is not a chemical reaction. Here's reviewing my mistake. My mistake that I had in the last set of slides was that I wanted to represent CO2, but instead I foolishly represented OC2. There's 2 carbons in here and 1 oxygen, whereas you can see clearly right here, there should be 1 carbon and 2 oxygens. That was my mistake. These reactants don't match with each other. I did have 2 individual molecules here, which is good, but the molecules themselves were not right. Just as a note, the right side of the equation, the products was correct. These products are correct, but the reactants were not on this side of the equation. Option to draw this. When we draw this, 2KH. K is bonded to H, which is what I have right here, and there's two of them. So I got one right here and one right here. We end up with two Ks that are not bonded together. That'd be a K2 in the basement. We would see a 2 in the basement. Just like in hydrogen, the hydrogen is bonded together. Those need to be touching. In order to represent things bonding in the models, they got to be touching. Why? Because they're sharing electrons. They're connected with one another. We should know that already from doing previous Lewis diagrams. We start with this bond breaking. See, we break this bond, and then we end up with a K here. Each of these bonds break, and then the hydrogens bond together. This bond breaks, this one forms. What do we start with and what do we end with? This one was C. We start with, this one is D. My apologies, D. We start with 2KH, and we end with 2Ks and 1H2. The other ones are incorrect because they're not telling you the correct number of each of the molecules. B is close, right? At the beginning. We start with 2K and H. No, no, no. It's not K and H. K is bonded to H. It should be KH. We're asking, what does this reaction make? So we're asking, what are the products of this reaction? The products of this reaction come after the arrow. Remember, the arrow is like, we make this thing. So that's being able to translate this equation. So we are making carbon dioxide and 2 water molecules, which is B. So a much slower reaction. Okay, this title doesn't make sense right now, but don't worry about the title right now. Using the law of conservation of mass, what has to go in the box? If we start with iron and we end with iron and oxygen, that means that there's definitely got to be some form of oxygen in this box. Otherwise, we're like making oxygen out of thin air. So we definitely need, if this is Fe2O3, we definitely need at least 2 irons and at least 3 oxygens. When we end up actually creating this, we can't have one oxygen by itself. We have to have an oxygen bonded to an oxygen, which ends up making these numbers out in front. I'm not going to quiz you on how to make those numbers out in front. I'm just going to have you be able to count. So if you can count that this is 4 irons on this side and that this is 6 oxygens because it's 3 O2s, an O2 here, an O2 here, an O2 here, there's 3 of them. That's going to be the same number of atoms as on the right side. 4 irons and 6 oxygens. So we're going to have 2 Fe2O3. 2 times 2 right here, we get 4 irons. 2 times 3 over here, we get 6 oxygens. This is talking about a different type of chemical reaction we can see. This chemical reaction is mixing together hydrogen peroxide, dish soap, food coloring, potassium iodide. When that happens, we see the reaction happen. So what reactants do we start with here? Those are the things that we start mixing together. And what are the products? The products are what happens after the reaction starts. The reaction doesn't start until we have all the reactants in it. The potassium iodide needs to be added, and then it explodes into this toothpaste. The break. So here is setting up our final learning goal assessment. So this is a dope show, Attack on Titan. It's a little bit scary, so if you're not into scary shows that are a little bit gruesome and bloody, don't watch this show. It's definitely gruesome and bloody. So if you're not into that, don't watch it. If you get scared easily, also don't watch it. But if you like those kind of shows, this is your show. So a little bit of context. So we're going to pretend that we are living in the world of the Titans. The world's changed. We're no longer the top predator, but rather the Titans are now the top predators. The Titans are the things that we have to run from and be afraid that we're going to get eaten by. The real powerful thing against the Titans is not our gear. Our limited gear may be able to fight the Titans, like in this one, Mikasa killing this Titan. But sometimes people are getting eaten by Titans, and our gear is not the perfect thing to fight it. But we need to use knowledge. Knowledge is the key here, folks. Knowledge is the key. It's key to our success. One thing that we have learned about the Titans is that the Titans have this hardening ability. The Titans have a hardening ability, and if we want to be able to defeat the Titans, we have to know more about the Titan hardening ability. They're taking their skin and making it super hard so that we can't cut through it like you see in this GIF. Like Mikasa running around with some swords, And she like goes and she like swings onto this Titan, like cuts out the back of its neck. Pretty awesome. But if the Titans harden, like some of them can, then we won't be able to cut through the Titan skin. So we need to know how this works. How we are going to find out about this is we're going to find out about a real life Titan, a real life armoring Titan. The Sea Pangolin is this little snail, and it's going to be how we learn about this. So if you're watching this video, you now need to open up the 2.5 final assessment and watch those instruction videos if you don't know what to do. That's it for me. See you, folks.